Hey guys, and welcome back. So in this video I wanted to talk about the challenges that we're going to face while creating this extra effects, this new effects. And with destruction we have multiple ways to add debris and secondary and volume trails. We can use particles or volumes, and we've talked about the particles that methods, and this week we're going to focus about using smoke solver to create smoke trails. And this smoke trail is not necessarily for the smoke for the trails from the RBD. It could be, for example, a dust element where we have a lot of object falling and we want some dust getting kicked in. Anything that is volume related, we're gonna learn how to do it this week. And the main challenge with this type of effects, at least for this project, is to create something that holds up from this angle, as well as when we are inside the volume and or in mid-range. So let me go through here. So this is another one showing just the volume itself, and I'll show a separate clip for this. But basically we have a wide view, an iBird view that shows everything, and then a lot of close-ups. And another one, this one is inside the volume, and this one is a close-up, this one is a close-up, this one is even more close-up. So we want something that holds up pretty well. And a lot of times when you work on these effects, you would have to create different versions, one per shot, basically one that holds up really well for this shot and you ignore everything else. And the way I've done it the way I've done it for this project is to sim everything at high resolution and cover the entire building, and this way I don't have to worry about doing close-ups and things like that. And let me show a version here. This is, I increased the density a lot to show you guys the details that are going, but inside the smoke itself here there's tons of detail. So for example, here we're getting the head hit and it's destroying the wall. You can see a lot of smoke is coming out and affecting everything else. Look at this area, for example, how it's bending and deforming. So there is so much details here. And I have another one that shows that uses less density, and it shows all the details. You can see it here, how the hand swing and everything, and all this is in the sim. There's no extra passes or anything. And the main challenge for this is that we need a huge sim to cover everything, a big domain at a very high resolution, and to do that is just an insane amount of work to be able to iterate. It's going to be immensely slow to do this. So my approach is to use clustering. And by clustering, I don't mean, this has nothing to do with the distributed sim or running a big res sim over multiple machines. No, we're gonna separate the sim into a lot of small domains. In this case, I'm gonna split it into 4, but we can go higher. And the split is going to happen in an interesting way. For example, let me do something. Let me show it in the viewport. So here, for example, I have the building, and actually I'm gonna talk about this in a separate video because it can get a bit complicated. But the main thing is we want to be able to cluster this geometry using a very smart logic that will tell us which part needs to be grouped together. And we need to analyze and figure out the pieces, how the geometry is moving throughout the time, and which parts make sense to be grouped together, and how to separate them. But we'll talk about this topic in the next video. The main thing that we're trying to solve now is how we can get this much detail without having to create a super high res sim and quickly iterate, be being able to quickly iterate on one cluster and then apply everything to the other clusters. And we'll continue this in the next video. Thank you guys for watching.